this video, I want to show you how you can find the sample size for a desired margin of error. Let's go ahead and read this problem. It says the weight of a small package of potato chips is normally distributed with a standard deviation of 0.1 ounces. The manufacturer would like to estimate the true weight of the chips using a 99% confidence interval with a margin of error less than 0.05. So how large of a sample size will they need in order to obtain this margin of error? So the desired margin of error, ME is what we're going to put it as, is 0.05 or less than that. We have a population standard deviation of 0.01 ounces, and we have a confidence level of 99%, which implies that our Z critical value will be equal to 2.576. All right, so I think we have everything we need in order to then calculate this. The formula, if we recall, is N must be greater than or equal to Z star times sigma all over the desired margin of error squared. So in this case, we can just plug and chug. Plug in the values that we have above. So we have 2.576 times our population standard deviation of 0.01, all divided by 0.05, the desired margin of error, and then squared. So this expression inside the parentheses is equal to 5.152. Square this, we get a value of 26.54, and we should always round up. The reason being is that we want a sample size that will give us a margin of error of 0.05 or less than that. So if we were to only put in 26 or round down, then it would be really, really close to 0.05, but it would still be a little bit bigger than that. So if we always round up, then we'll always have at least that small of a margin of error. So that means that we should have a sample size equal to 27 bags or more to obtain a margin of error of 0.05 or less.